right. Thank you very much. So, good afternoon, everybody. My name is Daniel Adeboye, Dr. Daniel Adeboye from University of Kwazulu-Natal. And I have also on the call Professor Govender, and we worked on this research together. So I'll just briefly take us through the topic teaching STEM subjects, an activated approach. From this standpoint, let me just quickly mention the fact that even though we are talking about STEM subjects, but we are going to be zeroing in on mathematics because we discovered that mathematics is one of the subjects that is most difficult for students at the lower level, both primary and the college level, the higher level. So even though we are talking about STEM subjects, but basically we are going to be zeroing in on maths, knowing that whatsoever applies to maths would also apply to all the other STEM subjects. So we'll run through a bit of introduction, then we'll look at the current statistics about the state of mathematics with the students. We'll look at what the research problem was, the research methodology, then we'll now delve into the approach, the intervention that we made use of, which is the ACT model. We'll share with us the results, and then the conclusion will come in. Now, so this is Emir, he's a Turkish boy. He always has issues with mathematics. He's always confused. In fact, because he doesn't like the subject and he also doesn't like the teacher, the maths teacher, he tries to distract himself while he's in the classroom. So he just distracts himself, finds something else to do just to while away the time. The problem is that himself with mathematics is a no-no. He doesn't like maths, but he's not the only one. Adeshewa from Nigeria also has similar problems. Once the exams are coming on, she falls sick. She's too anxious even to study. And so eventually she never really performs very well. This fear of maths and anxiety around the learning of mathematics has always been an issue with young people, young students in the schools. Now, the current statistics, which in the research we began to find out from Mbepechat, Drago, Servicing, and Bule in 2002, discovered that 78% of students have the fear of maths. This amount of students fear maths, basically. 67% of students fall sick before every maths exam. 72% of students score below 50% in every maths exam. Once it's a maths exam, at the end of the day, they do not do well in this maths exam. These are the statistics everywhere across the globe. Now, what is the problem? Generally, there are two problems I will be highlighting very quickly. The first is the traditional teaching approaches that we have all used. Of course, these problems are not strange. They are things that as educators, we are familiar with. The teacher wants to be the sage on the stage. He seems to know everything. And because he thinks he's the custodian of knowledge, so at the end of the day, he doesn't engage or involve his students in what he is doing. Of course, the second side to that is the teacher-centered approach that we have employed in teaching mathematics over the years. So over the years, the teaching of mathematics and other STEM subjects have been teacher-centered. The teacher is standing there and is trying to find out, so the content, the approach, the method, everything is suited, including the assessment, around the convenience of the teacher. Of course, it's grace-oriented. The genius is the one who scores all the marks, essentially. The second problem is the passive use of technology. So even when technology is being used to teach mathematics and to learn with mathematics, it's quite passive. We're familiar with the death by PowerPoint. This is a case where teachers make use of Microsoft PowerPoint in the classroom, but it's just a passive use. The students are sitting down wondering what is happening here. The second one is the copy-paste effect. I call it the copy-paste effect because of course, we want to use technology, but in actual fact, it's just the same way we sit through a YouTube video. Is exactly the same way we sit through a lecturer or a teacher in a class. It's the same way we sit through a YouTube video. Even the ebooks is just a pasting of the normal textbooks, physical textbooks that we hold. During COVID, when teachers were latching on the online teaching and Zoom teaching, a teacher actually taught the entire online class of almost 2 hours and he was muted. And the students tried every means to get across to him, but they did not succeed. So the fact that teachers may be struggling to use technology to teach maths and these other STEM subjects has not really given us the result that we are looking for. So we decided to run this action intervention research spanning through 7 weeks with 91 primary school students. And then the method that we use is the tests, which they did afterwards. We try to compare what the results of the students were before and then after the students went through these 7 weeks of intervention using the activated classroom model. So I'll be going ahead to discuss this model, but suffice to say that one of the biggest technology innovations that have come is what is called the flipped classroom. So even though I'll be talking about the activated classroom teaching model, the ACT model, it's a subset or a kind of an expression of the flipped classroom. The flipped classroom is a situation where rather than put content in the classroom and give assessment at home, the teacher flips that around and then gives the content at home, and then they come to class to hold a kind of a conversation. So as we can see, the activated classroom teaching model has these different pedagogical layers, from consumption to curation to conversation, correction, creation, and chaos at the very top. Let me just say that we want to move our students while teaching from one level to the other. So during the research, every week we went through these different pedagogical layers just to try and see how we could engage the students and bring them in to become active in the classroom so that we can see the result that it brought out for our students. So if I start with creation, so at the very lowest, students were asked to pre-watch videos at home on certain mathematical concepts. Rather than come to class and the teacher trying to do all of the teaching in class, they were asked to do the watching at home. And then when they got to class, they now began to hold conversations. So as we move up the layer, we start talking about conversations, and learning takes place in conversations. So students are allowed to discuss the solution and the sums even before the teacher attempts to solve it. This has a way of engaging the students. So in one of those classrooms, the teacher comes up and puts the students in groups, give them different sums and ask them to discuss the solution, hold conversations around it, and discuss why things are the way they are. This not only helps them to score better, but helps them to really understand and grasp the concepts that are being discussed. Moving up that layer, we get to the layer of correction. And in this layer, we are trying to say that we want to help the students to know why exactly things are the way they are. So we train them to spot errors. We train them to critique solutions. So at this point, one of the things that I did practically is to bring certain answers to questions that have not been, that has been pre-answered. So the students are to go through the solution step by step and try to find out, why did the student get it wrong? Why did the student get it right? Now, this training of picking out and critiquing solutions and steps helps them to better understand the concept. As we go a little higher that pedagogical level, and the higher we go, the more engaged the students are, the more active the students are in terms of what they are learning. Students are then asked to create explainer videos. And we all know that whatsoever we teach, we remember more. Whatsoever we have to explain to somebody else sticks more. So the students are asked to create explainer videos of some of the sums that they have walked through at home. Create it with your smartphone, explain step by step, and all of such things at that level of creation. Now, at the very top is the level of chaos, where students are required to not only solve a problem, but find the missing elements. So rather than release the entire information to the students, rather than release the entire, all the formulas and everything that is needed for the students to walk through, we withhold certain elements in the question and require them to find it out. That shakes them up a bit. They have to find out certain things. They have to make a bit of research. They have to probably go online to find out. I need this element to be able to solve this sum, but I do not have it. How do I find it? Now, that's the kind of thing we refer to as chaos. So moving from one level, one pedagogical level to the other at a higher rate engages the students and makes them to remember more. This is the kind of activities that were going on in the classroom throughout these 7 weeks. The result, definitely, is the fact that before the act intervention, 31.5% of the students passed mathematics with a score of 60 and above. Now, but afterwards, we can see that the percentage of those who scored 60 and above increased from 31% to about 54%, and that's positive. Even though it's not comprehensive and it's not as if that's all the results, but then it's a better result than what obtained with the way they were teaching before. And you can see that there's an increase of 8.7% in the mean after the intervention, which shows that there is a significant impact of the ACT model on the performance of the students. So we see that as we walk through these different layers, the students became more and more engaged and they began to understand more of how to move. In conclusion, we see that students generally and naturally have a fear of mathematics generally across the globe. The reason for this is because of sometimes the way the teachers teach the subject, and even when we try to use technology to teach, we do not do it the right way. We do not follow this pedagogical approach that engages the students in the classroom. So at the end of the way, the teaching is traditional, the teaching is teacher-centered, and the class is boring. At the end result is that the performance is quite low. But using this kind of an approach, the activated classroom teaching approach, a set of pedagogies, we found that the performance of students increased much more than what obtained before the intervention. So that's the kind of research that we carried out here in Nigeria, and we found that to be quite effective. Thank you very much. I hope that helped a bit. Thank you.